Assalamualaikum warahmatullahi wabarakatuh. Today I will be presenting for our ECG 353 mini project, which is prepared by me, Muhammad Rafiq Al-Hadi bin Rizal, Muhammad Lumak Hakim bin Muhammad Azni, Nur Hazira binti Muhammad Adam and Amin Raina binti Suhaimi. As you can see, we will be going through 5 different contents of this project, which are the introduction, discussion, analysis of data, justification and conclusion. For this project, we will be doing a site investigation, which is a field laboratory investigation that is required to obtain important information, specifically the soil physical characteristics and strength that is required in designing of geotechnical structures. There are 8 stages of SI that are involved in this project, and the method of SI that is used specifically for this project is the drilling of boreholes. By drilling the boreholes at the specific site, we will be able to conduct this standard penetration test, otherwise known as SPT. In this test, the soil sample is taken from the borehole and is used to identify the soil profile and the suitability of soil. From this test, we will obtain the N value of SPT test, which is known as the number of blows for the test drive phase, and it is used to discover the soil properties from the correlations of standard penetration resistance and shear strength parameters. Now I will present the discussions that were brought up for this mini project. The data obtained from borehole 1 and borehole 2 was up to 10.5 meters and 11 meters depth respectively. From borehole 1, at a depth of 1 meter to 3 meters, the soil strata was found to be clayey silt with traces of gravel. At the depth of 4 meters and above, the soil strata were found to be sandy silt with traces of gravel. From borehole 2, the soil strata were found to be granite rocks alternating with coarse sand. Therefore, both cohesive and cohesionless soil was found in the soil samples collected from borehole 1 and borehole 2. To determine the most suitable soil for the circular concrete water tank with load pressure of 100 kilopascals, the vertical stress imposed was analysed to a depth of 10 meters. Now we will continue by analysing the data. This is the tabulation of data for the first borehole. The SPT N value is taken from the test drive, which is the number of blow counts that are taken after the first 150 millimeters of penetration. The data is grouped in intervals of 1.5 meters in depth. Therefore, the limiting factor would be depth, which is 1.5 meters. Based on the source of our bore log, we can determine the type of soil and the consistency of the soil at the 1.5 meter depth intervals, which are also tabulated in the table above. The source of our bore log can be seen from the reference page of our written report. A similar set of data was tabulated for borehole 2, and a graph of depth by N value was created for both of the boreholes. This table shows the vertical stress distribution that has been calculated for a depth of 10 meters, and a graph of depth against vertical stress was generated. This is the soil profile that was created based on the data that has been analysed.
I'm gonna make this last forever, don't tell me it's impossible. 'Cause I love you for infinity. I love you for infinity. 'Cause I love you for infinity. I love you for infinity. Well, darling, my soul, you know it aches for yours, and you've been filling this hole since you were born. Oh, 'cause you're the reason I believe in fate, you're my paradise.
Now we will proceed to the justification for the model. The soil samples from borehole 2 have higher N value compared to the soil samples from borehole 1. Soil sample from borehole 2 is more suitable to build the circular concrete water tank. The granular soil with N value of 50 would have soil shear strength parameter friction angle of more than 41 degrees. Settlements may occur if the water tank is built on the soil from borehole 1. Choosing the soil from borehole 2 could prevent the soil from consolidating and shrinking. Borehole 1 is not suitable as foundation for the proposed circular water tank. The plotted graph shows a fluctuating graph pattern which determines that the soil is unstable. If the soil in borehole 1 is chosen as the foundation of the water tank, there will be a high possibility where the wall or base of the tank could crack and eventually cause leakage or collapse due to the low shear strength. To conclude this experiment, the site investigation is very important to ensure that the proposed structure is safe to be used. From the site investigation, soil properties can be determined to make sure that the structure would have a stronger foundation. To determine the soil properties, the standard penetration test is done to obtain the N value. From the correlations, suitability of soil as a foundation for the circular concrete water tank was determined. The soil collected from borehole 2 is chosen due to its high shear strength compared to the borehole 1. The soil collected from borehole 2 also have higher density than soil from borehole 1. Therefore, less water can be absorbed into the soil due to low voids ratio. The type of foundation that is used for this project is the earth foundation with concrete ring wall, which is under the tank shell and capable to support the imposed heavy load. Application of the concrete ring wall includes tanks with large capacity, tall or heavy tank shells and roofs that are self-supported and place a significant strain on the foundation beneath the shell. The advantages include offering a solid foundation for the tank shell, improving the distribution of the shell's concentrated load that results in a more uniform soil loading beneath the tank. The concrete ring wall also offers a flat, strong foundation for the tank shell's construction. That is all for our project. Thank you for watching.